as Chris mentioned, I'm going to be talking to you about a project I've done which comprises one of my chapters of my PhD, which I'm trying to write currently. So we've had lots of background about BTV, so I don't want to introduce it too much, but just to reiterate that blue tongue was historically sort of limited to the subtropics, but it expanded into Northern Europe more recently in 2006. And the virus successfully overwintered, so it re-emerged the following years in the following spring. And this overwintering really significantly contributed to the economic damage associated with these outbreaks because of the movement restrictions that are imposed during an incursion. The exact mechanisms of overwintering is currently unclear. However, what I'm interested in is answering the question of whether the Culicoides can enter and then survive throughout the winter during, in animal housing, which is quite commonplace in modern day farming nowadays. So you've got quite these large barns for both livestock and also equestrian establishments. So historical literature has suggested that eggs and larvae of Culicoides can survive quite a long time at very low temperatures, but there currently is a lack of data currently on the cold tolerance found in adult Culicoides. So I said about overwintering, so this is just sort of a nice schematic showing that in the spring and the summer, you get this really high peak of incidence of disease. And then as the year goes on and the temperatures decrease in the winter, it almost dies down to completely undetectable levels. And everyone thinks the virus has disappeared. And then all of a sudden, the following year, the virus re-emerges. So the virus is clearly persisting within the environment, but why is it not detected in the winter? And where does it sort of live throughout the winter months? So there are four main mechanisms or theories as to how this virus can overwinter. The first is that the virus can persist in immature life stages like larvae throughout the winter, but this is probably unlikely, or literature suggests this is unlikely. The second is that the adult midge can actually survive the winter months, whereas previously it was thought the cold temperatures kill the populations, but perhaps the adults now can survive the winter and continue that infection throughout the winter. The third is that the virus can remain persistently infected within an animal host, perhaps subclinically, which is why it goes undetected. Or lastly, that the virus can be transplacentally transmitted to its offspring. But I'm just focusing on the survival of these midges throughout the winter months. So I wanted to look at whether this animal housing can support the overwintering of these Culicoides. So I wanted to look at the abundances inside versus outside housing. And if they are coming into the housing, then the drivers and cues as to why they are entering those housing. And taking this further, looking at the role of temperature on their sort of activity and survival during the winter months. For this, I had a horse farm locally to here where there were 4 traps. So 2 were inside and 2 were outside. Of the inside one was in a large barn, sort of as I've sort of shown earlier, with the horses kept inside. And the other inside trap was just in an empty stable, so it just provided shelter. There was no horses ever present. The outside traps, one was outside a resting site, so a hedgerow potentially, and one was outside a muck heap, so hopefully a nice potential breeding site for the Culicoides. This was quite an intense study, which trapping was taken every day where possible over quite a few months throughout the winter. And from this, nearly 35,000 individuals were collected. And this plot just shows that there were significantly more Culicoides found in that inside barn where there were horses kept compared to any other trap, but there was also quite a large number outside the muck heap. Interestingly, the other inside trap, so the empty stable, had very low numbers. So even within the 2 indoor traps, you get a massive variation. And again, here between the 2 outside traps, you're getting a lot of variation. So it massively depends on the microhabitat that you have at each location. From the site, there's also not very much heterogeneity. So a lot of them are the Culicoides obsoletus complex. And we can also split them based on their parity status. So this kind of gives us an indication of where they are in their life cycle. So early in their life cycle, they'll be unpigmented, so a nice clear abdomen. But then they'll take a blood meal, which you can see in the abdomen here, and they'll use that to make eggs, and once they've had their egg batch, they will have a pigmented abdomen, as you can see here. If they've already had an egg batch and laid, they can then take a second bite, which is really important, obviously, in the virus transmission, because this is where the transmission of viremic or virus can take place. And as you can see, that the largest proportions found at each trap site were unpigmented. However, the largest proportion was found outside the muck heap. So again, supports the idea that this is a breeding site and Culicoides are emerging from this site. Also inside the barn, where you have horses, there was a high proportion of pigmented and also blood-feds, again supporting the idea that they're coming inside the barn to take a blood meal from the hosts that are present. Whereas in the stable you have, although they're still quite high, it's not quite as high, but the horses were obviously in quite close proximity because the barn is just behind the stable. And interestingly, there's quite a high proportion of gravids outside the resting site, so maybe they're going back outside to breed or to lay eggs. So this is just, shows that the abundances inside and outside can vary depending on what's found at each location, and there's differences within their parity level at each trap. So using some models, so a zero hurdle model and a count model, the likelihood of catching any Culicoides at all will always be highest in the indoor barn where their horses are kept, and secondary to that is the outside muck heap. However, the likelihood of catching anything is equally as low for the outside resting site and the empty stable. However, if there are Culicoides collected, then the actual magnitude of those collections, so the size of those collections, will be equally as high in the barn and the muck heap, and equally low in the resting site and stable. So although the barn and muck heap have similar catches or sizes, you're just more likely to catch some in the barn. So we can plot the abundances shown in the grey bars at each of the 4 sites, with minimum temperature in blue and maximum temperature in red. And as you can see, there is some sort of correlation between the temperatures and the abundances. When the temperatures get warmer, you allow for this expansion towards the end of the winter, which allows the population to expand. And the 2 lower abundances, you can see here, you don't really see many Culicoides throughout the winter. So how does that relate to the temperature? So when plotting the number of Culicoides seen here on a log scale and the maximum temperature, Culicoides were only collected on days when the maximum temperature was 6.8 degrees or higher. So anything where any days which were colder than 6.8 degrees, Culicoides weren't collected. So that again suggests that there's a sort of a cold temperature threshold for their activity. We can also plot it using sunset temperature instead of maximum temperature, as sunset temperature is thought to be the peak activity time. So again, Culicoides were only collected on days when the sunset temperature was 4.3 degrees or higher. But we can also look at the tolerance to cold. So I know they're quite small, but this graph is showing that hours spent over 2 degrees, time spent over 4 degrees, and time spent over 6 degrees. And you can see here that the more time spent at warmer temperatures allows for more collections of Culicoides to be made. So maybe it's the time spent at cold temperatures which also limits their activity rather than just the cold shock of temperatures. So for example, here you're only getting 3 collections when there was less than 15 hours spent at 2 degrees. But even when there was less than 15 hours spent at 6 degrees, you're getting a magnitude of different collections. So what does this mean for sort of arbovirus transmission? Well, the OIE define a vector-free period as less than 5 Paris Culicoides collected, which is based on their parity. So that basically means during this period, the risk of disease spread is very low, and therefore movement restrictions are uplifted to try and alleviate from the economic burden associated with an incursion. And here I've plotted the 2 largest abundant sites, so the barn and the muck heap, and the threshold of these 5 Paris Culicoides is in the black line. For the time period that I did this study, the DAFRA actually defined the vector-free period as the 20th of December to the 5th of April, which I've highlighted in blue. And as you can see, at my site at least, this was breached several times. So this might have been missed because sort of standard protocol at the minute for surveillance is done sort of weekly, whereas this was done daily. So you might have missed, for example, these daily breaches. But also the barn with warmer temperatures allows for the expansion of the vectors perhaps earlier on than you would normally find on a normal surveillance trap outside. So what can I conclude from this? Well, the cold temperature, there are cold temperature thresholds for the activity, so both a limit on their activity at a cold shock level, but also the cold tolerance of the Culicoides. The endophilic and exophilic behaviour is not completely discrete, so there's conflicting literature at the minute saying that Culicoides obsoletus prefer being indoors, and some say it prefers being outdoors, and my data just goes to show that there is no definitive answer, and it depends exactly on the habitat where you look. The housing, though, can perhaps allow for the extended adult Culicoides survival during the winter, and therefore act as a potential overwintering method. But importantly, the vectors can be present throughout the winter months. So is there really ever a true vector-free period? So this work could have implications in future overwintering preventions and control measures, so whether to inform farmers to stable or not stable their animals, but also influence policy decisions during the outbreak situations, perhaps even with defining that vector-free period. So I'd like to thank everyone who's helped me for my project, and I'll gladly take any questions.